COVID-19 ward monitoring system components needed: breadboard, Node MCU ESP8266, MQ2 gas sensor, DHT11 sensor, tilt switch, B10 buzzer, servo motor. I am using male-to-male jumper wires to connect the servo motor so that it should be connected to breadboard. And some LEDs of different color for the notification purpose. Hardware connections. Creating the positive and negative rails on a breadboard for the further connections. Red wire is connected to V-in and black wire is connected to GND. The servo motor, the data pin is connected to D7 pin of the node MCU. And the positive and negative pin of the servo motor are connected on a positive and negative rails of the breadboard. MQ2 gas sensor. The A0 pin of the MQ2 gas sensor is connected to A0 pin on a node MCU to read the data analog. VCC and GND pin of the MQ2 gas sensor is connected to 3.3 volt and GND pin of the node MCU. DHT11 sensor. The VCC and GND pin of the DHT11 sensor are connected to 3.3 volt and GND pin on the node MCU, and the data pin of the DHT11 sensor is connected to D4 pin on the node MCU. Tilt switch. One leg of the tilt switch is connected on a positive rail of the breadboard. The other leg of the tilt switch is connected to D8 pin of the node MCU. B10 buzzer. The positive leg of the B10 buzzer is connected to D1 pin of the node MCU, and negative leg of the B10 buzzer is connected on a negative rail of the breadboard. Five colors LED with 5 colors wire. The red LED is connected to D0 pin. The blue LED is connected to D2 pin. The green LED is connected to D3 pin. The white LED is connected to D5 pin. And last, yellow LED is connected to D6 pin of the node MCU. Further, the negative connections of the LEDs are made with the negative rail on a breadboard. So these are the final hardware connections for the project. project model assembly. I have created a model of COVID-19 ward, just putting the hardware at their right places in this ward, and final project assembly is ready. COVID-19 ward monitoring system project model information. This is my model for the COVID-19 ward monitoring system. I have attached the servo motor to the ventilation window, and servo motor is connected to the D7 pin of node MCU. Here is the ward lamp which is connected to D5 of the D5 pin of the node MCU. The DHT11 sensor for the temperature and humidity measurement, it is connected to the D4 pin of the node MCU. The MQ2 gas sensor to detect the toxic gases present in the ward, and it is connected to A0 pin of the node MCU. I have made an operable emergency lever with the tilt switch inside it. Tilt switch is connected to D8 pin of the node MCU. When we push this lever up, it gives the emergency signal. Here is the B10 buzzer, which is basically to give alert or the sound notification. It is connected to the D1 pin of node MCU. Here is the red LED which is connected to D0 pin, blue LED which is connected to D2 pin, yellow LED which is connected to D6 pin, and green LED which is connected to D3 pin. So this is the overall system for the COVID-19 ward monitoring system, and here is the connections and the node MCU. Hi everyone, my name is Manish Apothikar, and this is the final project presentation video for research teaser internship IOT at IIIT Hyderabad. My project title is COVID-19 ward monitoring system. This is the overall architecture of the system, and as per the overall architecture, I have built the demo COVID-19 ward. Now for the operation of this project, I have started the INCSE and MNCSE server to interface with OM2M. I have obtained this GUI from the MNCSE server, and from this GUI we will use this switch lamp 0 for operation of the lights inside the COVID-19 ward, and switch lamp 1 for operating the ventilation inside the COVID-19 ward. So this is my code for the project. Let's upload the code. While this code is compiling, let's log in to the OM2M server. Inside OM2M server, in this we have to go MNCSE, and this MNCSE I have created a application entity COVID-19 ward. Inside this COVID-19 ward, I have created two containers. First one is descriptor and second one is sensor values. So descriptor tells about the data being published onto the OM2M. So the format of the data is first value will be temperature in degree centigrade, second value will be temperature in Fahrenheit, third value will be humidity percentage, and the last value will be toxic gases concentration in ppm. Inside the sensor values, we will be storing the values obtained from the node MCU. So as you can see, code is being uploaded to the node MCU. Now code is successfully uploaded. Let's start the serial monitor. I have set the threshold values for the temperature 35 degrees centigrade and for the humidity 70. Also for the MQ2 gas sensor it is 500. So Wi-Fi connected ESP listener started. So we should get the values now. So here temperature is 32.6 degrees centigrade, in Fahrenheit 90.68, humidity is 66%, MQ2 gas sensor value is 66, and this data is sent on the ThinkSpeak. The second line tells us that the data has been published on the OM2M server as well. And as everything is under control, it is printing healthy environment in COVID-19 ward, and the green light is glowing inside the COVID-19 ward, indicating that the environment is healthy. So now let's check these values on the OM2M server. So if we refresh this, we get the sensor values, and if you go to the last value, that is CIN 7, we can see that the first data entry is 32.60, which is temperature in degree centigrade. Second one is 90.68, which is temperature in Fahrenheit. Third one is humidity percentage, value is 66, and last one is the 176, that is toxic gases concentration inside the COVID-19 ward. The threshold value for the temperature is 35 degrees centigrade, for the humidity it is 70, and for MQ2 gas sensor it is 500. So the data is successfully published on a OM2M server. Now let's check the ThinkSpeak interface. This is my ThinkSpeak account. I have created a channel naming COVID-19 ward monitoring system. So this is my channel for the COVID-19 ward monitoring system. It takes some time to publish the data on a ThinkSpeak. While the data is being published on a ThinkSpeak, let's try to switch on the light inside the COVID-19 ward with the help of this GUI. The first button will glow the white LED inside the COVID-19 ward, and second GUI will operate the ventilation window. So let's operate both of them. So as you can see, the servo motor is operated and the white LED is glowing. So it gives the notification that vent is on. So now let's switch off them both. So the LED is off. Now vent should also, so vent is off with the help of servo motor. So again it shows healthy environment in COVID-19 ward. So now let's check whether the data is published on a ThinkSpeak or not. So it shows about a minute ago we received an entry. So the last entry of the temperature shows 32.5 degrees centigrade in a field 1 chart. In a field 2 chart, the temperature is shown in Fahrenheit, that is 90.5. On the third field chart, the humidity percentage is shown, that is 66%, and in a field 4 chart, the MQ2 gas sensor value is shown 163 ppm. So now there is a healthy environment in COVID-19 ward. So let's operate this tilt switch, which will give the emergency alert. So the red LED should glow immediately and the alarm will ring. So as we can see, it is glowing the red LED showing that emergency alert, and it is showing on the serial monitor also that emergency in COVID-19 ward and immediate help is needed inside the COVID-19 ward. The alarm will ring for 30 seconds. So again it is showing healthy environment in COVID-19 ward and green LED is glowing. So now let's trigger the MQ2 gas sensor. I am using this essence stick for increasing the smoke inside the COVID-19 ward. So it should glow the blue LED and open the ventilation immediately as the value goes above 500. So as you can see, the ventilation is operated immediately and blue LED is glowing on. With the blue LED, there is an alert on a serial monitor that is toxic gases are present in COVID-19 ward. The alarm will ring for 30 seconds. The MQ2 gas sensor is sensitive to the various gases such as LPG, propane, smoke, alcohol, etc. So again, it is showing healthy environment in COVID-19 ward. So now let's try to trigger the MQ2 gas sensor again for the check of the toxic gas alcohol which is present inside this marker. It should again glow the blue LED. Open the ventilation. So as you can see, ventilation is immediately open. Blue LED is glowing and it is giving the alert that COVID-19 gases are present in the ward. The alarm will ring for 30 seconds. Again the system goes to normal. It shows it is glowing green LED and a healthy environment in COVID-19 ward. So it is showing on a serial monitor also. Now let's try to trigger the DHT11 sensor. I am increasing the humidity in the air by placing the wet cloth near the DHT11 sensor. It should glow the yellow LED and switch on the ventilation. So as you can see, the yellow LED is glowing, indicating temperature and humidity exceeds. It has also opened the ventilation window, and on a serial monitor, it is showing COVID-19 ward needs ventilation. The alarm will ring for the 30 seconds. So as the humidity near the DHT11 sensor has increased, it is again showing the COVID-19 ward needs ventilation. So now again the system goes to normal. It shows healthy environment in COVID-19 ward. So now let's turn on off this ventilation window. It shows the vent is off. Again the healthy environment in COVID-19 ward. Now let's try to trigger the DHT11 sensor for the temperature also. For increasing temperature, I am using a warm air from the hair dryer. It should glow the yellow LED and open the ventilation also. So as you can see, the yellow LED is glowing as increase in temperature goes beyond 35 degrees centigrade. The ventilation is operated and it is giving on a serial monitor that COVID-19 ward needs ventilation. So this was the overall operational video for the final project of COVID-19 ward monitoring system. Thank you all.